Hello, today we're going to talk about Newton's first law of motion. Why do we study Newton's laws of motion even though physics has gone beyond that and now we consider it classical physics? We know it's a bit more complicated than that. For two reasons. One because Newton's laws of motion changed the way we looked at movement and advanced science a lot. And it also helps students understand the basics of how the world works and how things move in the world. Secondly, because if we simplify our problems, if we simplify our cases, well, Newton's laws of motion still can be applied. So they can still be applied in most exercises that we consider for students. Okay. So, what is Newton's first law of motion? It is it's also called the law of inertia. Why? Inertia is the tendency of an object to either stay at rest or stay in its continuous movement. Okay. So the Newton's first law of motion, if the net force acting on an object, so all the external forces acting on an object added up, if the net force on an object is 0, so they all cancel each other out, well, the object will either stay at rest or keep moving with a constant velocity. Okay. What does this imply? It implies that to be able to move an object or to be able to accelerate or decelerate an object, we need a force. This might seem basic now and even stupid, but if you think of it, it goes against our normal everyday life experience. If we throw something, it will eventually stop. If to be able to move with a car, we need to keep on feeding it energy through the engine. So things tend to stop, and that is because in our real life, the net forces acting on objects is not 0. There is a force called resistance, either because of between materials or with air, that will eventually stop the movement that we're considering. Okay, so yes, we do observe that things don't tend to move on their own. They need a force to be able to move. So that part of Newton's first law is understandable, but the second part isn't so much, because we need to apply forces for things to move, to keep on moving, or to accelerate or decelerate. The variable that relates this the difficulty of moving or of stopping an object, or of moving or of changing the speed of an object, is the mass, what we call the mass of inertia, which is curiously equal to the gravitational mass. Okay, so this lorry will stay at rest until I apply a force. Or if the lorry was moving in a surface with no resistance, it would keep on moving at the same speed with no acceleration until I apply a force to either accelerate it or decelerate it. Okay? You can see it if you throw a disc in a surface that has little resistance, for example in ice. It will keep on moving nearly infinitely. Okay? And now we know that in space where there's no air resistance, you can throw something with a speed until it gets to a velocity, and once you stop applying the force, it will keep on moving at that velocity. Contrary to the space movies. In space movies, the engine of the spacecraft keeps on moving the engine, the spacecraft, but it wouldn't be necessary. You would only need to accelerate the spacecraft until it gets to the velocity you want, and then you could stop the engines and it will keep on moving at that constant velocity because of Newton's first law of motion. Okay. Once we understood that this was so, that life, our Earth is a special case, and that it has a force, the net force applied on objects is not zero, and then things fall because there is a force, a net force that is not zero, the resistance force, and makes them stop. We started to understand a bit more things. Okay, and it explains also, for example, why you need to wear a seatbelt when you're in your car. If you're moving with a certain velocity in your car and suddenly the car brakes, the inertia of your body will tend to keep on moving at that same speed, because on your body there's no force applied. The force has been on the car. So you need a seatbelt in order to apply the force and stop you. Okay, so again, Newton's first law of motion. A body will stay at rest or will keep on moving with constant velocity, so no acceleration, if there's no external force applied, or if external forces, the net external force is zero. Okay, or in order to start moving an object, or to change the speed of an object, you need a net force that is not zero. Okay, so now let's look at the mathematics of this important law of motion. So there are two ways to express this law of motion mathematically. The first one is that if the net force applied on an object is zero, so if the sum of the external forces of the forces applied on an object is zero, then that means that the velocity or the speed is constant. Okay, so that has two implications. One is that if the initial velocity was zero, then the final velocity will be 0 too, and it will remain at rest. But if the initial velocity was not zero, then the final velocity would be the same as the initial velocity, and it will keep on moving with that same constant velocity. Okay, so that is a way of expressing this first law mathematically. Another way to express this first law mathematically is using derivatives, if you already know them. So if the sum of the net forces is zero, then that means that the derivative of the velocity with time equals zero. So we already know that that means that the acceleration is zero. So this means two things again. If the change in velocity is zero, then either the initial velocity and the final velocity were zero, rest, okay, stay at rest, or the initial velocity and the final velocity were not zero, and then it means constant velocity. So this is the mathematical way of expressing this law. So again, the law is very easy. In order to make something move, or in order to change its velocity, we need to apply a net force which is different to zero. We need to apply an external force that is different to zero. Okay?